Good morning, students. Today we are going to see an introduction to linked list and difference between array versus linked list and different types of linked list like single linked list, doubly linked list, circular linked list. Small introduction to linked list. So what is linked list? It's a data structure which allows to store data dynamically and you can manage data efficiently. It looks like this. See, we call the rectangle symbol as node. Here, the diagram we have shown three nodes as an example. The first node having element A, second node having element B, third node element C. So only three elements in a linked list we have assumed for simplicity. The last node having data C and every node having two field data and next field. See, next field normally contains address of next node. Header always contains address of first node. The last node next field indicates null. So null means it indicates end of list. So what are the features? Header points to the first element. Successive nodes are connected by pointers. What is the need for pointer? The data elements in the linked list is not stored in continuous manner. That's why they are connected by pointers. The size can be grow or shrink during the execution. It's a dynamic data structure. So in case of array, the last class itself we have discussed that it is continuous storage location. But in case of linked list, it is not continuous storage location. So here, the main thing here is in linked list, adjacency between any two elements are maintained only by means of pointer because memory is not stored continuous manner in linked list. Linked lists are suitable for inserting an element at any position. You can insert at beginning or any position or at end. Deletion also, you can delete data at the beginning or end. But in case of array, insertion deletion at the end is easy. Insertion at beginning is very tough in array. It's not that much efficient. So how to implement linked list in C? So before implementing linked list, you have to know how to define a node. How to define a node? With the help of struct keyword, I can define a node. So struct node. So here I'm having two fields. First one we are going to assume it's an integer data. So the data type we have used is here int data and the pointer variable data type is struct node. So it is given struct node star next. So struct node star next. It points to the same node. So we call it a self-referential structure. So what are the types of linked list? One is single linked list, very simple linked list, what we have discussed earlier. Say for example, the same example A, B, C, three data elements, every node having only one pointer field. If we node having only one pointer field, then we call it a single linked list. That pointer variable, it contains address of next node. So what is doubly linked list? A node going to have three fields. One is data field, and the one is next field, and the one is previous field. So next prev. Next contains address of next node. Prv contains address of previous node. So how to define a node in doubly linked list? Same struct node. So instead of two variables, here you're going to have three fields. First one is data field. Next one is pointer variable next, and now it's pointer variable prev. So next going to have address of next node. Prev contains it's a pointer variable. Both next and prev are pointer variable. So doubly linked list is a collection of nodes linked together in a sequential way. You can travel in both directions. It is also referred as bidirectional linked list. First node, previous field points to null value, and also last node, next field also points to null value. So what are the advantage of singly linked list? Very simple, going to have only one pointer field. Okay, what are the advantage of doubly linked list? Here you can travel in both directions, but the problem is we need some extra space to store prev node. What are the different types of circular linked list? Circular linked list means normally in singly and doubly linked list, the last node next field points to null. That indicates end of a linked list. But in circular linked list, the last node next points to the first element. So this concept is applicable for both singly and doubly. So circular linked list, it is of two types. One is singly circular linked list and the one is doubly circular linked list. In singly linked list, if last node points to the first, then we call it a singly circular linked list. In doubly linked list, if last node points to the first node and first node previous points to the last node, then that one we call it as doubly circular linked list. So in this example, here we are going to create a simple singly linked list. So instead of telling int data, here we are going to get three data. One is roll number, name, age. So data field only, again having splitted into three fields. They have defined three nodes, N1, N2, N3, all belongs to the data type structs STUD. From the user, roll number, name, age, we got it with the help of scanf function for all three nodes. So ampersand n1 dot roll, ampersand n2 dot roll, ampersand n3 rol, etc. So after that, pointer variable n1 dot next. What is n1 dot next? It's a pointer variable. It contains address of second node. So how to get the address of second node? With the help of ampersand symbol, you can able to get it. Once everything is done, we can traverse the entire list. So n1 is the first node. Okay. So p is another pointer variable. In p, we are storing the address of first node n. Then we are printing what is the value available in p, role name, age, and we are traversing further. So p equal to p next. Now p move to the second node so that we can able to print values in all three nodes. So the diagrammatically, say I'm having three nodes. Okay, instead of having integer data, we have defined roll number, name, age in the data field, and next points to the N1, next points to the N2, N2 next points to the N3. Since N3 is the last node, N3 next points to null. So null indicates end. So another example for creating a single linked list. So here I'm going to store 10 values in a linked list. Same node declaration with the help of struct. To create 10 values in a linked list, the user-defined function create list is used. So how many nodes? 10 nodes. So n is equal to 10 and the user-defined function create list is invoked. Inside the create list, with the help of malloc function, we can create memory and dynamically whenever you need data memory, you can done memory allocation with the help of malloc function and you can assign data. You have to read data for all 10 nodes from the user with the help of scanf function. See in here new node data equal to data means this data is data given by the user. So with the help of for loop, inside the for loop, so for all n nodes, memory is allocated. If new node is equal to null means memory is not allocated due to some reason, at the time you can break from the loop or else create a new node, load data, new node next is null. So what is temp? Temp next is new node, temp equal to temp next. You have to update the temp. So diagrammatically I have given, so elements inserted 10, 100, 200, 50, 30 and so on. So what are the operations on linked list? So different operations you can do. Traversing a list. Traversing in the sense for printing, you can traverse a list. So print the first element in the first node, then move to the second node and print the element in the second node and so on. Traversing, displaying all elements. Or insertion anywhere, beginning, end, anywhere, deletion. Like that, many operations you can do it on a linked list. So very simple thing is traversing. So how to traverse a list? Inside the main traverse list is a user-defined function which is invoked in the argument header is given. Without header, we cannot traverse the list. Header contains the address of first node. So in the traverse list, one argument is given as header. So if header is null, it indicates that list is empty. We can't print any data. In the else part, we are using some temporary pointer. The temporary pointer also belongs to the data type struct node. So temp is equal to header. Now temp also points to the first node. So if I'm going to give printf temp data, it is going to print the data available in the first node. So if I'm going to give temp equal to temp next, it is going to move on to the second node. So till temp is not equal to null, repeatedly I am executing the statement temp data and temp equal to temp next. So to traverse all nodes in a linked list. So when it comes from the while loop, when it reaches the last node in a linked list, so it comes from the while loop. So insertion, so very simple. This example clearly depicts how to insert node at the beginning. Say assume that I'll read three elements in a singly linked list 20, 30, 40. Now I want to insert 10 at the beginning. So now the new node is named as new node. Fine. So new node next has to be connected with a node which is having data 20. Correct? So new node next points to head. Correct? New node next, and head has to be updated. So new node will point to the head node, make the new node as a head node. Now the new node is a first node, correct? Fine. So you have to update the head node. So this is a code. So if I want to insert node at the end of singly linked list, say already 10, 20, 30 is available in the singly linked list. Now I want to insert a new node with the data 40. So a new node is created, 40 is loaded. Since it is a last node, new node next is null. I want to link the node which is having data 30 with this 40, correct? So I need move some temporary pointer, have some temporary pointer, move to the last node. So this is my last node. So last node next is my new node. So this is my last node. So last node next is equal to new. So to insert node at any position, it's okay. So if I want to insert 30 after 20, that is also possible. Only 2-point adjustment required. So node which is having 20, 20 next should point to the node which is having data 30. 30 next field should point to the node which is having data 40. So only 2-point adjustment is required. So traverse to n minus 1th position and connect the new node with n plus 1th node. Now keep temp pointer in n minus 1th node. So this is only 2-pointer adjustment. See, in case of array, it is very difficult, correct? If I want to do insertion at the middle in the array, it is very, very tough. You have to push many elements down. But in case of singly linked list or doubly linked list or circular linked list, it is very, very easy to do it. Thank you, students.